On today's show, we're going to show you how to install the SKR E3 DIP board from Bigtree Tech into the Ender 3. Stick around. Hey, welcome to the First Layer. My name is Richard Cleveland. This is the show that explores the world of 3D printing. And today is no different because we're getting our hands dirty as we dive into the SKR E3 DIP board, which a lot of people have bought as an upgrade for their Ender 3s or CR10s to get that 32-bit action. We're going to talk a little bit about what the 32-bit gives you as an advantage over your regular 8-bit board, and show you all the things that you're going to need to get it into your system. We've got a lot to cover today, so let's jump right into it. And we got a couple of bonus tips for you near the end, so you make sure you want to stick around for that. So let's talk about the SKR board. The board itself, when you buy this board, it literally is a tiny, tiny board. It's designed so that all you have to do is basically pull it out of the package, do a little bit of configuration with your pins, and you're all set. It comes with some heat sinks as well. It comes with a little cable. You know what they say about a short cable? You got to get close to your source if you got a short cable, where you're plugging it in. That's a bad joke. Don't tell anybody that joke. And you get a little rubber ducky. I love the rubber ducky. Rubber ducky, you're the one. We're now demonetized.
Kind of fun.
Yeah, we're now demonetized because we did a Sesame Street song. There's also a card in there that has all the official website. Now, I'm going to tell you straight up that the documentation for this board and the install of this board, anything that's out there right now, and no offense to some of my brethren here on YouTube, but they all suck, because nobody has done this specific board yet. They've done the 1.3 and they've done the Pro, but they haven't done the DIP version. Some people have done the Mini, which is very similar, and we're going to talk a little bit about that. But first, let's get this out of the package, and we'll show you exactly what's on this board. We're going to give you also a really neat close-up of what the actual stepper driver looks like, but we can't get this underneath that electron microscope. Okay, so here we have the Bigtree SKR E3 DIP version 1.0. Now, some of the features of this board are, first and foremost, you have replaceable stepper drivers. So if you should have a problem with your stepper driver for whatever reason, you can actually replace it very easily. Now, this board can be set up for UART, and I won't go too much into UART because I think we've discussed that on another show already. But what it does is it basically gives you some advantages and some additional features that will benefit your 3D printing in the long run. Now, this kit that we have here is provided by Spool 3D, and they sell this on their website. We'll put a link to it down below. This one comes with 4 2208 stepper drivers as part of the kit, and all you have to do is just configure the board a little bit, and we'll talk a little bit about that. Now, on this board, you can see that there's a reset button right there where my big finger is. So you have a reset button. You've got your USB right here. You've got your card reader right here. One of the nice features is it has a fuse that is replaceable on this board, which is really nice. It has 2 fan headers, fan 0 and fan 1. Right there. Now, fan 0 is going to be for your part cooling fan, and fan 1 is going to be for your always on fan. Now, in the case of the Ender 3, you have 3 fans basically on that machine. You have your part cooling fan, you have your heatsink fan, and then you have a fan that is for the case itself to draw in cool air and keep the components nice and cool while it's running. So what we're going to do on this one is we're going to change up the stepper drivers. You can see that there's jumpers on all of the pins, And we're going to insert the picture to set this up for UART. We'll go to that now. So as you can see in the picture here, if you want to use this with the UART setup on that is already set up on the stepper drivers, and we're going to get a close-up of those stepper drivers pretty soon as well, you'll notice that the third set of pins down is the only one that you want to have a jumper on to enable UART on this board for the stepper drivers that come with it. And that is the TMC 2208s. These are all from Bigtree, so they're all branded together, just like you would if you were branding together the MKS board. You'd probably want to use MKS jumpers as well. So from Bigtree, the SKU on these are 77B000302. There's 4 stepper drivers, the TMC 2208 UART. They will be designated as UART, which means that there's a jumper that is already soldered on the actual stepper driver itself. And we're going to talk a little bit about that as well. We'll pull up a picture and show you what that looks like as well. All right, so what we're going to do, you can see that all these have their jumpers on them. So we're just going to pull off the jumpers that we don't need by getting a pair of tweezers, popping them in there, and taking off these little jumpers. Let's go over to the close-up camera, and you guys can have a quick peek at that. So these are the little jumpers that you're taking off, and they are, you can see I've already taken one off the top there. Came from that location right there. Okay, so I'm going to go and continue to take off these and get this set up so that we can put those stepper drivers right onto the board. Okay, so now you can see that we've set up the board to enable the UART capability on the TMC 2208 UART versions of those stepper drivers. And all we're going to do is the third from last is leave that jumper on there. That's all you need to do. That's all you need to do for this particular board in terms of getting it ready to put on your stepper drivers. Now, going to the stepper drivers, I want to just grab this box here real quick. I'm going to close it up so nothing falls out. So you can see that when you're buying your stepper drivers, if they're not already enabled, if they are enabled, they'll say UART behind them. If they are not enabled, they will not say UART. Now, again, the UART gives you some additional functionality you can set up through the firmware. We're not going to go into much of that today, but suffice it to say that when we do get it set up, you guys will be able to experience what it's like to not listen to your 3D printer and have a little bit more capability for yourself down the line. You'll also notice down here on the bottom it says X4. This particular kit is for the E3 DIP, the SKR E3 DIP from Bigtree, and it does only come with 4 steppers. Now, yes, you can put on the 2209s, you can put on just about any board that you, or any stepper driver that you want, and it doesn't necessarily have to be a Bigtree stepper driver. You can put on MKS, you can put on Large, whatever you want, whatever you're most comfortable with. But if you want to make sure that if you want to have that UART capability, then you're going to have to make sure that you take the jumper on the stepper driver and make sure that it's shorted out. And there's documentation available to show you how that's done. We will link to it in the description below. All right, so let's have a quick peek at a close-up of this section that we were just talking about. You can see that we have 4 sets of jumpers here. There's 3 jumpers per set. You want to make sure that that jumper that is on there is again in the 3rd position, and it is on the red row, not a red and black, but on the red row. Okay, so now when we take the stepper driver, boom, 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 let's put that down there so you guys can have a quick peek at that. This is a close-up of the stepper driver. And this is the TMC 2208 version 3. Now we can see where all the pins are. You'll also notice that we've got 3 little pins that stick up right here. We're not going to worry about those pins. They're for another application down the line, so we don't have to really worry too much about that. But let's flip this over. Okay, what you're going to notice here is down here in this corner, see if I can get in on it. See right there that they've put in a resistor right there. Let me just, it's hard to do this when you're not used to it. You see that across 2 pins, there's a resistor. That's what's enabling the UART on this particular chip. So this is now ready to go directly into the board. All right, so having a look at we've now had a look at the actual stepper driver. We're going to install it onto the board, and it couldn't be easier. You line up the red side with the red side and the black side with the black side, and you can't mess it up. It's pretty easy. You're just going to seat it all the way down till it stops. If you have to put too much force on this, you're doing it incorrectly. So we're going to just take the rest of them, and we're just going to populate the entire board all the way down. We've got all 4 of these. One other indication that could make a difference to you is you want to make sure that this little potentiometer, and let's see if I can bring it into the microscope here a little bit. There we go. This little potentiometer, you want to make sure that it is facing towards where the power is going to come in on the board. So there you go. There's where the power comes in, and there is that potentiometer. So that's another indication of making sure that you've got these orientated correctly. You can see that we've got red on red and black on black there. All right, so we're here inside the Creality Ender 3, and you can see why we're going to replace this board. Now, we could have replaced this board with a silent board from Creality if we wanted to, but again, that board doesn't give us a lot of the functionality that we're going to get out of this new 32-bit board with a little bit of a different architecture. We're going to go into how to set up the firmware for it in just a few minutes, but first I wanted to show you why this board has limited functionality. First and foremost, we burned out the connector for the power, and that could be done for several reasons. First and foremost, I think, and this is my own personal opinion, all you guys that are electronic gurus can tell me if I'm wrong, but they've tinned all of their wires on the end. So it's not making a really good connection. So I would rather them not be tinned and then just put them into the terminals and screw them down. That way you wouldn't have the problem. But I think the reason that they tin them is so that they don't have any stray copper that might short out on another terminal. And that's just the way they do it. Now, you can also see on here that we've got the pin 27 board here down at the bottom of your screen that is there for the BL Touch. And it does cause some issues in space. So we're going to get rid of this whole board. And basically all you're going to do is you're going to take out this board and put the new board in. So we're going to go ahead and do that. We'll show you what it looks like once it's all installed. All right, so we've gone ahead and installed the board. It's a pretty straightforward install. We've got a spot for the BL Touch, which is right there. Now, you're going to notice that there's 2 fan headers, and there's one right here, and there's one in the back of it, right over there. Now, fan 0 or F0 will be for your part cooling fan, which will be the yellow and red, or pardon me, the yellow and blue wire. Now, there is a separate fan header. You're probably wondering where we plugged in the heatsink cooling fan. There's actually a terminal on the board, which is right next to the power terminal. This is the power terminal. And then this line of terminals right here. The very first set is for your fan. Anything that you want to run off 24 or 12 volts, that's what you're going to run continuously. Now, there is another fan for this particular one, and we'll just switch cameras over to the other camera here. Okay, so on the lid of our Ender 3, we have a fan, and it has a fan header already connected to it. We don't have to change around any cabling. We're just going to put this directly onto the board, and this fan will now run continuously from the time you start your machine till the time that it stops. My recommendation would be to change this fan out when you get a chance. This is a sleeve bearing fan, and you're probably going to be much better off with a ball bearing fan. We'll go back to the board here for a second, just before we button this up. Okay, you're going to notice here that on these stepper drivers, we have two different types of heat sinks. We have a low profile heat sink in the silver, and then we have the high profile heat sinks in the back here. The reason we had to go with these smaller ones is because the tall ones interfere with that fan. So we had to make the change. We went to smaller ones. We're going to take this, we're going to plug it into the fan header on the board, which is that empty fan header that we have right there. And then we are going to fire this up and do a smoke test. All right, so the board's installed. No magic smoke, which is always a bonus. Now what we need to do is we have to download a few programs in order to be able to manipulate the firmware, which is based on Marlin 2.0, which is still in beta as of the recording of this video, which I believe it's going to be released fairly soon. But because of the different architecture for the processor on this particular board, unlike the standard Arduino ramp sort of setups that we've been used to, this now uses a completely different chipset. So we have to manipulate the firmware with a little bit of a different program. It's not very hard. We're going to show you what to do here right away. So let's start by going to Visual Studio Code. This is the first piece of software that you're going to need, and we'll just go over to my desktop now. All right, so we're here at the Visual Studio Code. You want to make sure that you have Visual Studio Code. Hit the download link, download it, and you're all set to go. Just install it. There will be a couple of other things that we're going to do once we get it installed. I've already installed it, so I'm just going to kind of gloss over that. The other thing that you're going to need is the download for Windows 64 or 32. This is the desktop GitHub environment. This is going to come in handy when we're trying to compile our software. And finally, you're going to have to go to the GitHub for Bigtree for the SKR E3 DIP version 1.0, and you're just going to download the complete zip file and then unzip it. Don't worry too much about anything in here. Once you've got your Visual Studio installed, you are going to have to install Platform IO. Now, this is what we're going to use to manipulate the Configuration H and Configuration Advanced H files in the Marlin firmware for this printer. So what you want to do in order to be able to get this installed, all you want to do is just go over to the extensions, which is this sort of broken piece of square, and in the search just type in Platform IO. Once you see the Platform IO IDE come up, you're going to click install. It will tell you down in the window below here that you need to restart it. Once you've restarted, this is how your environment is going to look. Okay, so now we have all of the necessary tools that we need to manipulate our particular file. So now we're going to go over here, back up to our environment. We are going to open a folder. The folder that we want is the Bigtree SKR E3 DIP folder that we've unzipped already. We'll just double click that. We'll go into firmware, and then we're going to talk a little bit about that. So the next thing that you want to do in order for the software to keep your bed leveling mesh is uncomment restore leveling after G28. Oh, let's back up there. There we go. And you're just going to uncomment it by taking away those two slashes. Now the next thing that we want to do is go to our advanced config. You'll see now we've got a secondary tab open here. So the next thing that we want to do is turn on our baby stepping. And what baby stepping is going to allow you to do is make minor adjustments in the height of, or in your Z height as you're laying down that first layer, so you can get exactly what you need in case you're just a little bit too far away. Now, one of the other things that this is going to do for us, and we're going to turn it on, we're going to show you where that is that this will also hold that number and transfer it over to your Z offset. So let's go and hit Control F, and we're just going to type in baby stepping. And now we're gone down to enable baby stepping. So we're right here. You can see that on line 1166, it says define baby stepping. We want to make sure that our baby stepping is defined so that we can make those minor adjustments. Now we're going to go down to line 1186, and we are going to enable this line right here that says define baby step Z probe offset. Now the reason that we're doing this is so that our Z offset is held when we baby step down so that we can get that right amount of squish for the material that we're using. Now there's one other one here that we're going to use, and that is always accessible right here on line 1177. And we are just going to, again, define that one, and we are all set. Now, we've covered everything that we need to cover to get our firmware ready to use on our Ender 3 with the BL Touch. So what we're going to do now is we're going to go down to the bottom. All right, one other thing that we need to do is go and search for Trinamic. And it is going to take us down to the area where our Trinamic drivers are, and we are going to find the line. All right, a couple of other minor things that we'll want to do here to make sure that we get our stealth chop working, which is part of the 2208 UART setup. On line 1798, we are going to change this from 12 volt to 24 volt. And the reason that we're doing that is because we are using a 24 volt power supply. If you leave it at 12 volt, it may cause some issues. Now, the other line that we're going to change is we're going to come right down here to this line that says define line monitor driver status. That's the one we're going to do on line 1811. Again, we are going to just uncomment that so that it's part of our normal setup. By enabling this line 1811, what you're doing is turning on the smart features of the UART steppers, which you have now on this particular board. We'll get into more of what UART is in a completely separate video because it's a topic that really is all on its own. So now we're ready to go ahead and compile. We're going to go down here to our line, a nice blue line. You'll see a little check mark, and we're going to start there. We're just going to click that little check mark, and then it is going to start compiling everything for us and tell us if we have any errors. We'll come back. It'll come up here in the terminal. This is where it's going to tell you if you have any errors or not. If we did everything right, we shouldn't have any errors. It does take a minute or two, depending on the speed of your PC. All right, so it's compiled. We have a successful compile. So all we have to do now is close this. We are going to go into our file folder where we downloaded our Bigtree master file to. We're going to click on firmware. We're going to click on Marlin. Now you'll see a bunch of files up here, file folders up here. The one that we want is the PIO environment. So that would be this one right here. Third one down. You can see it highlighted on your screen now. We'll double click that. We'll double click the Bigtree Mini. Now you're going to see a file in there that says firmware. This file is the file that you need to copy to your SD card or your micro SD card. You'll copy this to that card. Then all you're going to do is take it out of your computer and put it into your sweet, sweet new setup printer. Okay, once you've installed it and everything is correct, you will see this screen come up and it should take you right into your Ender 3 ready environment. Now the menu system is going to be a little bit different from what you're used to. You'll notice that you have motion now at the top. We'll just click that, show you what's in there. There is where you can move your axes up, down, sideways, front to back. You can also do an auto home. You can level your bed, set your fade height, disable your steppers, and that is the last one in that menu. Then we can go to temperature. We can set the temperature, preheat PLA, preheat ABS, just like we normally would if we wanted to preheat. In the configuration file, we're going to see advanced settings. If we press that, We can set our home offsets. We can set the velocity, acceleration, jerk, steps per millimeter, TMC drivers, temperature, filaments, and going into some of these others, like the TMC drivers, we can set our current and our stepping mode. We've already set that up in the firmware. It's already been pre-done for us, so we don't have to really bother with that. We can probe our Z offset if we want. We have our BL touch, self-tests, and resets as well. We have our outage recovery is turned on. So what that means is if you have a power outage, just like it did before, you can recover once the power comes back on. We can also set the temperatures for our ABS and PLA configurations just by clicking the button, and we can change these temperatures from 185.45 to whatever we want. Now, typically, I set mine at 200, and for the bed, I'll set it at 60. That just gives me a nice round number, and it's usually about where I'm printing my materials anyway. We're not going to bother too much with that now. We can restore our failsafe. You should never have to hit this unless something drastically goes wrong. And then below that, we have about our printer, and you can see we go in here, we can get some printer info. We know that this is bug fix 2.0 of Marlin. 2019-07-19 was when this was done. We can get some board info, and it tells us exactly what board we're running. It tells us the protocol and the baud rate in which it's communicating. And this is kind of a neat feature. We can see our thermistors, which is kind of neat. Our maximum temperature is 300, as you can see there. And the other one is set to 125. Now, what those two numbers represent, the top one is for your hot end and the bottom one is for your bed. Your bed should not get over 125 degrees, and your hot end will not go any hotter than 300 degrees. If you're using a standard Ender 3 head or a Creality head, you may want to leave that at 275 degrees, because once you start getting above 240, you start to melt the PTFE tube inside the hot end, and that could be disastrous for you in the long run. So it's not that difficult to set up the SKR E3 DIP board. Not many people have really explored it. We've kind of taken you through sort of the Cole's notes, abridged version of how to do it. Try it out for yourself if you're interested in this board. It's a great upgrade for your Ender 3, your CR10. It fits in all of those cases just because of the architecture and the way that it's designed to fit into multiple different Creality machines. So with that said, one of the nice things about this, because we've got the 2208 Trinamic drivers on it, makes this machine virtually quiet. The loudest thing on here now is the fans. So you no longer are going to hear that wee, wee, wah, wah, anymore. So you can watch your favorite show and have your printer in the same room with you. I like to have my printer, that way I can see what's going on. So with that said, my friends, that's all there is to setting this up and getting it set up on your next Creality machine, or, you know, maybe you want to do it on a bigger machine. Who knows? There's all kinds of boards out there now from SKR. They're very reasonably priced. You can check out spool3d.ca for all of the parts that we talked about today. I'll leave a link for them down in the description below. In the description as well, you'll see links to all of the software that you need to get started and setting this up properly for yourselves. So with that said, I want to thank my staff who's in the house today. There's Brian behind the control board. There he is. Whoop. Jess is over here keeping the sun out of my eyes. My lovely wife's around here somewhere as well. And she's making Cole's notes for me for something else later on down the road. We want to thank Spool3D for all of their help as well in giving us this wonderful space to use and bring you these shows. So thanks to Spool3D. They've got everything that you need on their website at spool3d.ca. Everything from printers to SKR boards and accessories, anything else that you need, including filaments. So go check them out today at spool3d.ca. With that said, I'm going to run out of here because I got a lot of things to do myself today. And you guys have yourselves a great weekend. We're going to see you back here on Saturday night at 7 p.m. Mountain Standard Time for another live stream. We'll see how that goes. Make sure you've got your questions ready. Until then, my friends, remember that the first layer is always your foundation to a great print.